Lesson 13, red-black trees. At the moment I will not add an example for this chapter. I will add one as soon as I reach 15 subscribers on my Patreon account. You'll find all information in the description section below. And this is what a red-black tree looks like. So you have black nodes and red nodes. As we've seen before in the previous chapter, ordinary trees become much slower when items are inserted in already sorted order. Ascending or descending is the same, as they become unbalanced. Unbalanced trees that link the list performances are similar, as for both that arrangement is one dimension. Red-black trees properties. Each node is either black or red. The root is always black. If a node is red, its children must be black. Black nodes might have black children. Every path from the root to a leaf must contain the same amount of black nodes. Every path from the root to a null child must contain the same amount of black nodes. Null child is, for example, a potential left child of a node with a connected right child. This node might never exist, might never be created altogether. Null child are always considered to be black nodes. If any of the previous rules is violated, you must intervene on the nodes to either make them rotate or change their colors. Colors flips change a black node with 2 red children into a red node with 2 black children. Right rotations move the top node to the position of its right child, while its left child is promoted and moved up. Left rotations move the top node to the position of its left child, while the right child moves up. Red-black trees that do not break any of the listed 6 rules are almost always well balanced. And that will be all. Thank you very much.